Thanks for coming to the multi-cloud talk. My name is Josep Blanquer. I'm an architect at Rightscale. What I want to do with this talk is to give a little bit of a... Is this good? Is this too high? It's good. Okay, good. I want to give a little bit of an overview of kind of what going multi-cloud means, what are the challenges and benefits from doing it, and also a little bit what are the things that Rightscale can help you in fulfilling this multi-cloud goal. So this is kind of the outline that I have for the talk. I want to make sure that we all start from the same baseline of what do I mean by a cloud, what is multi-cloud, and really what's different when thinking about it. And then I want to go through the different things that Rightscale can help you with to abstract these things across different clouds. If we have time, we can go through a multi-cloud example, or I can show you some things on the on the dashboard. I guess that it's not a big group, so we can make it as we feel. So there's going to be time for questions in the end, but if there's something that is burning, I think that you can ask me. So, what do we mean by cloud? Well, I'm not talking about like services like App Engine type of thing. I'm talking about something that exists somewhere physically that you can access through an endpoint. Usually, yeah? You talk to an API endpoint, and you're doing things in the cloud. So it's an important thing to note that Amazon Web Services is not a cloud, right? It's a collection of services. EC2 is one of these services, but EC2 itself is not a cloud. It's a type of cloud that defines certain APIs, right? Eucalyptus or Cloud.com or vCloud implementations are not clouds either. There are ways that you can, there are things that you can use to create a cloud. So a cloud is really like something like EC2 East, EC2 Asia Pacific, your garage cloud implemented with Eucalyptus. Those are clouds. Availability zones are not clouds either, just they're little pieces of it. What are all these clouds that I'm talking about? The first thing, I guess, to think about, that most people think about is that, well, there's a few clouds out there. There's the Amazon clouds, there's the Rackspace clouds, maybe there's some large private cloud installations, and there's going to be more and more providers coming up. But I think that the key here is that the landscape of the cloud is not this. The landscape is much bigger, right? There's a few big fish there, but there are going to be many, 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 many more clouds around. And that's the landscape that we actually have to look forward to. So, all these different clouds, where are they in Rightscale? So, I guess that most of you guys are already used to, I hope that most of you guys are already used to using our dashboard. You're used to, the different Amazon clouds, US East, West, Asia Pacific. And in here, for example, this account has a Cloud.com implementation of a private cloud and Rackspace too, right? So for the private cloud, you actually have to register it on your own because we don't know that you have a particular private cloud in your garage, right? So there's a particular registration process that you add the endpoints and some keys, and then a new menu will appear. For the public ones, we take care of immediately showing them in the dashboard for you. So you only have to enter your credentials with, say Amazon or Rackspace. So what does multi-cloud mean? So there's different ways to define this. So I think that it's good to start by trying to define the holy grail of multi-cloud. What is the nice thing about multi-cloud that in the end we would like to achieve? Going multi-cloud means being able to deploy your applications across different clouds, probably across different cloud providers, which means that really have different APIs. Maybe some of them are public, some of them are private. On top of that, being able to really evolve your application by adding more clouds as they are available, or as you see fit, because they have particular features that they provide that you're interested in, and basically manage all these in a very seamless way, in a very integrated manner. That's kind of the holy grail of that. So one thing that I want to say right off the bat is that multi-cloud is not about choosing which provider you want to use. It's about choosing which providers, in plural, you want to use, right? And integrate things across. So these can actually, can turn out to be something that people can think, oh well, this is going to be like the holy grail of having these applications that can span across everywhere and they're highly available, yada yada. And while we eventually will get there, we have to start thinking about the first steps to get there. The first steps, we think that it's basically a good first step towards starting to think about multi-cloud is to use this cloud portability sort of paradigm in which you want to prepare and deploy things in one cloud, but in a way that in a cookie cutter way, you can actually do the same thing with another cloud. So it doesn't mean that you have, you're using 5 clouds at the same time to provide your service, but at least you can deploy in a cloud and use the same tools to deploy in a private cloud in the same way or in another public cloud. So there are many, many benefits, right, from going multi-cloud. The typical ones that one can think of is, higher redundancy, DR sites, geo-presence to really, get closer to your clients, choosing the cloud in Asia because your, clients are in Asia, that type of stuff. There's many things that we can leverage from multi-cloud in the public way, in the way that they probably charge you, in the way that the dynamicity of their resources, that you probably are not going to run out of resources if you use one of the main cloud providers. You can also want to leverage existing investments that you may have by creating your private cloud, and then combine production and testing or a hybrid of both using multiple of them. The typical example of being able to cloud burst servers when you're out of capacity in your private cloud into the public one, or the other way around. There's really many benefits from being able to choose from different clouds and cloud providers. But really, to get to that point, there's many pain points that one has to surpass. Mainly is because all these clouds are very, very different. The APIs, to begin with, differ dramatically. They export a different set of resources. They support different formats. There are versions, so they change along their own life cycle. Their abstractions differ. Like networking abstractions could be really, really different from one cloud to another. Like security groups, like in Amazon, and VLAN implementations from many of the other clouds that we're actually seeing. You could have load balancers or port forwarding, NATing, ACLs. It's quite different. Same thing for storage architectures. How do you define? I want these disks. Can I define disks in my VM? Are they going to be attached? Are they going to be detachable? Am I going to be able to snapshot them? These things change quite a bit from provider to provider. And the list goes on. Different hypervisors, different ways to manage images. The list of supported features really, really differs. And I think I was giving an example this morning about there's some features that don't even make sense for some clouds. I probably don't want to have spot market pricing in my private cloud, right? So there's going to be quite a bit of disparity of things that the different clouds offer. And they're truly different beasts, right? With different semantics. How could we start thinking in these abstractions? What is different from trying to think in a multi-cloud environment versus in a normal cloud environment? So to me, this is kind of a little bit of an equivalent of what you would have to do if you want to create a new application that is really composed of different sub-applications that are written in different languages. You're going to have to bridge the gap such that all of them, they coexist together, giving one single nice application. So I think that a lot of the features or issues are actually shared. So I just have a few points here to give some, I guess, best practices or some words of advice of things that are involved in this area. One that is very important is deploy using cloud specifics. Take advantage of what the clouds provide, the specifics, but design using higher level abstractions. That's actually a quite important point. You want to be able to use the features that the cloud provide, but don't lock yourself in. Right? You want to be able to do something in this cloud, later on in that cloud. And maybe that feature doesn't exist, but at least your architecture will allow you to somehow map it to something else. You obviously have to have tools that translate these high-level concepts into the cloud specifics. I'm not only talking about API calls and formatting parameters and things like that. I'm talking about things at a higher level again, like backups. I may want to take a backup of a disk, but different clouds may have different ways to take backups. Right? I have to be able to translate my take a backup into do an EBS snapshot if I'm in Amazon, or do an LVM sort of snapshot and upload to cloud files if I'm in Rackspace. An important thing too that changes in multi-cloud is that you have to design for geographic dispersity. We're used to work in a single cloud, and once you go over, you suddenly have latency issues. You have to start using the public network, the transfer times, the bandwidth. Things change, so you have to plan for that. The same way, you have to start thinking about how to share data across, right? You're not going to have like gigabit Ethernet connectivity between your machines. So you have to make sure that you have certain plans for moving data across. And last but not least, kind of ties back what I was saying before, it's very different to try to design an application for a multi-cloud application for a high availability, self-healing type of system compared to designing something that you can deploy in the same way in different clouds, right? Kind of a cookie cutter type of thing. So know these differences when you're designing your application. They're really different. So how does Rightscale help in this thing? Rightscale helps by basically providing a unified view to all these abstractions. And I'm going to talk about three very important abstractions and some of the things that are coming down the pipe that really help realize this homogeneous view of dealing with multiple clouds that are potentially really, really different underneath. So in particular, we're going to take a look at the server abstractions, the server template abstractions, which are a configuration definition, and the images that can span multi-cloud. So one by one. So let's start with the servers. Servers are something that probably you're quite used to deal with, and the key here is that you may not think about it, but servers really look and smell very similar regardless of the cloud that they're in. When you create a server, you basically do the same basic stuff. You create them, you start them, you can run operational scripts, you can monitor them, you can put alerts on any of the metrics, you can list them together in mixed deployments, you can see servers, some of them will be Rackspace, some of them will be Amazon. You're used to dealing with them in very much the same way, although really they're potentially in many, many different, far and very different places. The next abstraction is quite important, and that's server templates. So I'm not sure if everybody is familiar with server templates, so I'm going to take a quick parenthesis in explaining what these abstractions are before going to why they're important in the multi-cloud area. So just going to take a couple minutes. The idea of a server template is to simplify the management of a server configuration. Server template will allow you to say, I want this software installed in the machine when it comes up. Okay, so a typical way to deal with this is basically having images and having to, bundle images for every single application that you want to launch. A custom MySQL image with the CentOS operating system. But then MySQL has a newer version, so you need to burn a new image. And then there's some configuration that is not quite what you like, and then you have to reburn the image. And suddenly you start accumulating these tons and tons of images over time, and it's very difficult to keep track what they have, how they change, and what do you need to do to make them to fix them. So what the server template model gives is a way to say, well, let's not deal with images. Let's do the following. Let's take just a few very, very, very base images in the bottom, just keep a small set of them, and then build a configuration on top of that. So let's start with a base image that doesn't have much, and then specify what you want to install and configure it on top. That's the holy grail of the server templates. That's what they try to achieve. So let me give you an example and how it looks. So a server template looks something like this. It has a base image, a CentOS 5.4 image, say for example, that is Rightscale enabled, and then a set of boot sequence scripts or recipes for the people who build templates with Chef, that basically specify what needs to be run when the machine boots. These scripts can install stuff, they can configure things, whatever you want. Then there's also some other scripts that you can specify in the server template that you can execute at any point in time. They're not going to be run at boot time, but you can always go to the server and say, execute this script. So here's an example of this. If we start with the right image, say for example a server template for MySQL. This is the simplified one, right? So what could you do? You can install the monitoring software for Rightscale. You can install the MySQL server binaries. You can configure it. Maybe you want to restore the last backup, attach an EBS drive with the latest data for your lineage, set up the DNS, blah, 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 blah. Start the services. Okay, that machine is now operational, and you have very nicely defined what you want on that machine, right? Changing these things at the Rightscale level, really editing the scripts, it's 100 times better than having to figure out where to go on the operating system, change the file, rebundle, and boot again. So that's kind of the idea of a server template. And then these operational scripts that I was talking about means that at any point in time I can go and say, perform backup. on a running server, and that thing will be executed. And these things could be chef scripts, could be shell scripts, Ruby script, whatever you want. It's something that can be executed in the machine. And they're actually very transparent. All the templates, you can see what's happening. So it's not a black magic there. So if we take this a step further, you can see that server templates are really software configuration abstractions. They basically allow you to bridge the gap between an initial image, some basic characteristics of an image, and a fully configured server. And this works basically across operating systems, because the way you program these templates, these scripts, could basically leverage and see what operating system you're running on, and install things one way or another. If you're in Linux, if you're in CentOS versus Ubuntu, you will install an RPM versus some other sort of packaging system. So they bridge operating system differences, but at the same time, if you build them well, they will bridge cloud differences. They may see, I am in this type of cloud. To really restore a backup, what I'm going to do is get this EBS drive, attach it here, and I know which one I'm getting because it's the one that is in the lineage of my master backups, and here you go. And if it's in a cloud that doesn't support backups, maybe it has to create a drive and download the data from cloud files or S3. Right? So these are very powerful abstractions. These templates also, I didn't say it, but they do get, you can specify certain user inputs to configure these things. So for example, one part of the template that restores your application code, you may have to configure it by saying, okay, this is the Git, or this is the SVN URL, and these are the credentials, right? So it's all configurable from that point of view. They can also partially help in sharing the data, because they can potentially download stuff from global sites. Server templates. So that's another very powerful abstraction that allows you to configure the same thing, to configure the final result that you want and apply it to different clouds. So now there's an interesting thing here that probably some of you guys have thought of, and that is that I said it bridges the gap between a starting point, a base image, and a final configuration. Well, a base image is it cannot be really a cloud image, right? Cloud image is some bits that exist in the cloud. So I cannot really use that low-level image if I want to launch the server template on that other cloud, right? So you need, again, something that is slightly higher that says, I want an image that is Ubuntu 8.4. And then this is the minimum requirements that the template needs, and then I need to somehow know which low-level image this Ubuntu 5.4 will correspond to each of the clouds. So that's what basically the multi-cloud images do. Multi-cloud images are really an abstraction of a minimum set of requirements, but they're really not bits. There isn't an image that is an MCI, what we call an MCI, right? It's going to be a mapper, a mapping between this concept of and some cloud specific things. So for example, I want to have an image that is a CentOS 5.4 image, and there's going to be a mapping perhaps that maps to a particular AMI in EC2 East image, and a mapping that maps to ID 1234 in Rackspace, right? So when I launch an instance, server template that requires the CentOS 5.4 multi-cloud image, I'm going to have to see under which cloud I want to realize this, and then following this mapping, I'm going to use one or the other base images to really start putting the template. So that's, again, is another thing that elevates the concept of an image a bit above the cloud image management. So these MCIs are versionable and publishable like the templates. So you can create your MCI mappings, you can publish them, and then people in your infrastructure, for example, can use them. You can version them. You can add more mappings when you add new clouds. So it's very much like templates. So we don't have to get into the details, but MCIs don't only map particular AMIs or images in the cloud. They also have other things like what is the type of image instance types and what certain data you want to pass when you put an image on a given cloud. So from the point of view of our write images, every time that we rev a version of a write image on each cloud, we will publish a new MCI that basically has something that says this is the new MCI image, and it maps to all these new clouds that we've published in the individual clouds. So we take care of our write images and do this mapping. This is just a screenshot that you probably cannot see that basically has a bunch of MCIs that we publish for our right images, and here in the middle basically lists which clouds these MCIs have low-level mappings for. So we have some Windows images, 34 bits, 32 bits, 64 bits, some CentOS images, some Ubuntu images. So we take care of our right images mappings in this way. Some of you guys may be wondering, what do I do if I have a private cloud? You know, Rightscale cannot really go and plop in an image in my private cloud and add it to these mappings, and it's true. So if you want to start using images and do a mapping to your private cloud, you basically take any of these MCIs, you clone it, add your mapping. You probably have to download the image into your actual cloud, map to that image, and then you can launch a template that uses this MCI in the same way. So as long as the image that you map has the basic functionality of CentOS 5.4 with the right link enabled images, you'll be able to put the template. Let me talk about something that is another abstraction that we don't have right now, but it's something that it's coming down the pipe, something that's going to become more and more important as we start thinking about multi-cloud deployments that really are live in multiple clouds at the same time, and how these applications will have to talk to each other. And that's about data, locality, and mobility. And this is farther down the road, but it's going to be a big hurdle to overcome. That's basically because different clouds, they're really isolated. They don't share much. So you really have to do everything on your own. So I don't have to go through all the details here, but when you go to a multi-cloud environment in which several clouds have to be communicating, applications in several clouds have to be communicating with each other, you have to think about things of, I'm gonna have to use a globally accessible service to share data across. Maybe put things in S3 in one end and you get them from the other. Do I need to programmatically transfer data across in the same way that you would bring a backup tape from the East Coast to the West Coast? There's some big data equals long time type of issues there. Do you need to maintain replicated, online replicated stuff so you can take over at any point in time? Those are actually quite difficult questions to answer depending on your application, but I want to bring up to your attention that there's something that is also equally important, but probably is not, we're not really thinking too much about it quite at the moment, and that is keeping track of where your data is. It's not only necessary to know how to share data, but you also have to know where your data is. If you have a master backup that you have to promote from cloud A to cloud B, suddenly you have to track that the main part of the data now lives somewhere else. So the lineage of this data and where they are across time is going to be something very important for complex systems. So we're thinking about some of these abstractions, but there's nothing really solidified yet.
Question.
Yes?
You have three products that can do like a B2B exchange, but within the same cloud. Like in Amazon, you have two different, one exchange here and one exchange there, and you securely transfer the data to them.
So the question is that if that there are products that can somehow transfer data and sync things up. Yes, there are, but when you want to do these things that usually are thought from a point of view of living in the same geographic zone data centers. Maybe it's not the same data center, but it's close. So you can use these products, but some of these products, if you really want to use them in a true geographic environment, you're going to probably have to roll a fair amount of things on your own. And if you don't, then it means that you're going to have to start using products that are fairly complicated. NoSQL databases, replications across data centers, and it's possible. I'm just saying that this is something that is fairly complex to accomplish. But yes, there are companies that are focused on that.
So when you refer to keeping track of your data, what granularity are you guys thinking about doing that? Like, obviously you can do the file systems, but what about stuff that's in S3 that you're keeping track it down to the individual file?
Right, that's a good point. So the question is about, what are we thinking about keeping track of data? What kind of data? As this keeping track of S3 data fall into the picture. It's just like is only about volumes and snapshots. And honestly, I don't know. I think that one thing that is very important to keep track of is volumes and backups of volumes. Call it snapshots if you want. That is extremely important. And that and the relationship between those things and the deployments in your servers. You want to keep track of what happened with the backups of my main database. My main database may have been promoted 5 times, so things have shifted around, but I want to recover that and analyze it. Right? I want to recover a backup from a week ago, and I have to know where to go get it. Maybe it's a pointer to S3, right? So we don't know yet. But that's kind of the idea, just being able to have higher level abstractions that have some sort of history attached to them. I guess that if you guys have ideas on how to, what the needs are for these things, please let us know. Because I think that some of these things are really unexplored. So we're trying to be a little ahead of the curve, but honestly speaking, it's difficult to know.
Right, we've got a homegrown app for this, but maybe we'll discuss requirements.
Yeah, okay. Be happy to. Okay, so how am I doing with time? Okay, I think I'm kind of out of time a little bit, 5 minutes. Okay, let me give you a feel of a use case. It's a use case of cloud portability. It's not this, super self-healing, geographically distributed system. And this is kind of a very simplistic case in some ways, but I think it illustrates the things that can be possible right now. And let's take an example of a company that has a very simple Rails application. Let's call it, I don't know, like a gaming app or a personal calendar type of thing. And they have a lot of clients in the US, so they have some deployment there. They grew at some point, and they started a new deployment in Europe. Completely separate sites, right? They don't have to share a common database, say for example, like embarrassingly, shardable applications. So from their point of view, right, you want to probably have the same deployment structure on both sides. So you kind of want to do things in the same way. And at the same time, they may be thinking about opening a beta site with the same functionality, maybe in a reduced way. Maybe they don't need that many servers, they don't need that much redundancy and things like that. And at the same time, they have probably developers that develop this application that want to test what they're developing. So they may have another, say, a private cloud. I don't know, this is a cloud.com logo in which they have the development and the testing, right? So there are interesting features in here to note. For example, here, what I basically color these things is that there's going to have, say, for example, 2 load balancer machines, or 2 that basically funnel traffic to a set of backend Rails application servers, and then maybe they have a master-slave setup, MySQL. So there's like the load balancer portion, the Rails portion that could be or could not be running, say, in the same machine. You can have a scaling only Rails array behind it, and then the master-slave stuff. In the reduced setup, maybe you only need 2 machines that have combined the load balancer and 1 Rails in 1 box, and they don't need maybe the master-slave. And maybe in the test and dev, they need 1 machine that has the whole stack. Okay, so how do you put this together? What is this cookie cutter model that I was talking about? It's actually quite simple from a logical perspective. We're going to start by preparing some scripts on some chef recipes and group them together. Maybe you have some recipes that know how to configure a load balancer and install it. Some of them that know how to do the same thing for Rails, and some of them that know how to do the same thing for MySQL. Once you have these bits, you can start packaging them together in templates. So adding more or less of these scripts in a template. So for example, for this scenario, you could have 4 templates that basically are just pieces of this. You can have a template that only has the MySQL, or a template that only has an app server, or a template that has an app server and a front end, a load balancer, or one that has everything. And that's what the developers will want to use, right? They want to launch 1 machine for this template that has everything. They don't need redundancy, they don't need master-slave backups. Once you have this, you specify which base images these templates are relying on. In this case, you just say just 1 single multi-cloud image, Ubuntu 8.4. Okay? And once you have these, you basically can put this together into a server. You can create a server that says, I want a Rails front-end server that uses this image, launch it. Right? So that's basically what happens here. So in terms of servers, these will be 2 servers that have two pieces combined. And these will be an array of servers that only have this template. Right? So in a way, the way I was sort of depicting these figures are certainly very convenient in how we actually have built these little Lego sort of systems, right? So from the point of view of the test and dev, one machine has everything, and in this case, maybe you only need 3 machines to realize this, beta sort of site, right? So that's kind of the idea of the cookie cutter model, that if you do these templates correctly, using the right multi-cloud abstractions, using the right software that knows how to install things differently depending on cloud, then spinning up a new production site in Asia is just really a matter of dragging and dropping and some clicks. So that's kind of we think the first step towards this higher level myth of multi-cloud sort of idea. And I think I'm out of time, but without having to go through this summary, one thing that I want you guys to take away is that it looks like that it's an extension of cloud computing, but it's really another change in the paradigm, in the way that we had to rewire our brains, I think, going from the hosting environment to the cloud environment. It's kind of a very different way to architect stuff. I think the multi-cloud, it's another step in that direction. You have to think differently. Don't get into the same traps. Open your mind, so to speak, because things are going to be actually quite different. And honestly speaking, we are just beginning to scratch the surface on any of these deployments.